Hey everyone, welcome back to another episode of the Futurum Tech Podcast. I'm your host, Daniel Newman, Principal Analyst, Founding Partner at Futurum Research. Excited about this interview series doing with Micron, where we're going to be talking to Chris Jacobs. Chris is the Vice President and General Manager of Embedded Market Segments in the Embedded Business Unit at Micron. Chris, welcome to the show.
Thank you, Daniel. Great to be here. Looking forward to our conversation today.
It is always great to have you here. Really enjoyed over the last year or so having several great interviews with Micron, both here and on my companion podcast, the 6.5. We just did one on your latest beta announcement, the one beta announcement.
Yes,
So many exciting things going on at Micron. So we got to use all of our platforms all the time to make sure we have different places to put all the news. Going to talk a little bit about IoT and embedded security today with you. But, first and foremost, let's just get started and do a quick introduction of yourself. I gave that big, long, important title. What does that mean? What's a day in the life of Chris look like at Micron?
So in my role, Daniel, as the VP and General Manager of the market segment organization in the Embedded Business Unit, I'm fundamentally responsible for interpreting the market environment, what our customers need, and translating that into product development strategy and go-to-market strategies for Micron, right? So if you look at the embedded business unit, fundamentally we're involved in any kind of intelligent edge application. Where processing is on the edge, and I hope we have an opportunity to dive into a little bit deeper on what we mean by that. But specifically, automotive and industrial applications, as well as select consumer applications, where there's a lot of data processing and data storage requirements on the edge of that particular network. So I'm responsible for really interpreting that market and engaging with the customers so we could deliver the type of system solutions that will really drive those applications going forward.
Yeah, it's going to keep you really busy over the next year too, as we see so much change and transformation going on in all those spaces. The promise of the edge and IoT has been talked about so much across the board. And by the way, this isn't new, but we are starting to see it accelerate and catching scale. So maybe let's start there. First of all, Micron, very well known for memory, but the company's been busy diversifying. A big part of its success story has been moving into these more commercial, industrial spaces, getting outside of just devices, because we all know that that's going to be a tougher market now in this ebb and flow of what's going on in the economy. But talk a little bit about the Micron Intelligent Edge portfolio. Give us a little background.
Sure. So, maybe I could start off, Daniel. When we look at these particular applications, we really want to bring innovation to these emerging applications. There's a lot of opportunity with memory and storage on the intelligent edge for Micron to really bring some new and interesting types of products. We talked recently about Authenta, that's security at the edge. We'll talk a little bit more about that later, I hope. But again, there's innovation is really part and parcel to what we want to make, because we want to drive the market into the future here, not just react to it overall. And certainly this has to be done in a framework that delivers the right product at the right cost, because these devices are becoming much more ubiquitous in our life. Whether that's in automotive applications or maybe B2B industrial applications, but even in consumer applications. And so again, making sure that a full system solution at the right performance and cost trade-off, that really is how we think about the intelligent edge portfolio. But if you just look at the industry today, Daniel, some specs, and I'm looking at my piece of paper here, by over the next few years, about 75% of all of the data that is going to be shipped around our network is going to be produced outside of traditional data centers, right? And so things on the edge, whether that is IoT components or an automobile, which is considered an edge device in many instances, a lot of data is going to be produced at those locations. And when we look at the intelligent edge, what we mean, Daniel, is that there's processing at that edge location, right? So not only do you have sensors there, but you have some processing capability and obviously some memory and storage as well that can store that data and that can enable that processing. And that's absolutely critical to enable these applications of the future. Things like low latency. If you just think of an automobile, right, and a highly automated automobile, that automobile needs to interpret the environment around it, and then make some decisions whether or not to brake or to steer out of the way in an autonomous fashion. All of that has to be done on the edge in the car itself. We can't afford the latency to ship that to some cloud processor and let some advanced algorithm take advantage of that and then deliver a solution back into the automobile. And so we see the intelligent edge just increasing in overall bandwidth requirements, density requirements from a memory and storage uh, point of view. So overall, a lot more memory and storage capability needs to be built into the intelligent edge as compared to just in the last few years here on it. You know, if you look at what we have done over the years, we are number one in share in both automotive and industrial applications. That has allowed us a unique position, Daniel, where we can see these market requirements evolve and we can react to them and then drive some interesting product feature sets into the future. And so, you know, we talked a lot about, for example, automotive. And recently, you may have seen our low power DRAM 5, LP5, ASIL D memory for automotive applications. So ASIL is a functionally safe standard. We were first to market with this ASIL D support, again, needed for secure processing and storage at the edge. And there's a list of other innovations that we have brought out over the years in which we were first to market, whether that's in storage, like in UFS applications, or we mentioned Authenta for some of our NOR products. These are all examples of innovation that we want to bring to the intelligent edge. And again, you'll see more to come into the future.
Yeah, we'll double click on some of the things you just mentioned
Sure.
and appreciate that overview. Let's start with Authenta. You actually just mentioned that. You know, with the proliferation and the rapid growth of data at the edge and compute at the edge, you're also seeing increased intrusion, increased issues with security. And those risks are unlikely to change. But Micron, at your recent electronic event in Munich, announced some updates, momentum around Authenta security. Talk a little bit about those updates and even just the general contributions there, because I don't necessarily know that Micron and security are necessarily always lumped
Right.
together.
Yeah.
It might be a good connection to make.
You know, Daniel, it's a very good question. But if you think about it, right, in terms of security for these edge devices or these IoT devices, the storage and memory is actually an ideal place in order to put various security elements to protect the entire system. Most notably, we have a portfolio of NOR products, and in many instances, the NOR device is what stores the boot code in many of these systems. And so putting security elements within that NOR device just protects the entire system. And so you know that that particular firmware that is on that NOR device is indeed the firmware that was meant to be there. And obviously, over the air updates are becoming much more prevalent now. And so you have to have the ability in order to update that firmware. Again, the Authenta technology allows you to validate that that firmware update is indeed intended and is the correct firmware to update on that device. And so again, there's a hardware root of trust. So this is where Micron, again, leveraging its memory and storage technology, augments it now with the security capability within the devices itself. And so you're right, Daniel, perhaps when we talk about security, Micron is not top of mind, but where the system will be most secure is that you have to secure the storage device that stores the code of the system. And that's where Micron is in a perfect position in order to implement this hardware root of trust. What we talk when we talk about Authenta, if you go back and you look at some of the things that we've done recently, obviously we're building out a portfolio of hardware here, not only Micron hardware, but we are also engaging across the ecosystem with other partners to implement Authenta technology into their devices as well. Again, we see this as a broader ecosystem play because obviously we want to make sure that Micron memory is used in every system around the world, but in many instances that's not the case. And so we want to engage with other memory and storage providers, and they can implement Authenta as well and enjoy their own revenue stream using this technology. So in addition to that hardware root of trust, that foundation, there is the Authenta Cloud platform, which effectively allows a very easy way to update the firmware, get the status of these various devices that are on your network, and also allow for some billing. Right, so the idea of some fee for services and billing to generate this revenue stream. This Authentic Cloud platform allows Micron and other companies to realize a revenue stream when they implement these secure IoT devices. So again, that's it in a nutshell, Daniel. And what you'll see over the next few years, we're going to continue to build out the Authenta portfolio in Micron, but also engaging in the broader ecosystem as well, and making sure that this becomes the de facto standard for hardware root of trust in our industry.
Yeah, it's going to be a massive challenge, and really appreciate you sort of breaking that down and simplifying it. The one thing that comes to my mind too is, well, first of all, can I just make light, because I do that on this show. I like to have a little fun. When you said that's it in a nutshell, I couldn't help but think of that. Remember Austin Powers, that part where he
Oh
goes,
yeah.
"Oh, me in a nutshell." Yeah, we got to have a little fun on this show, but it's like, wow, I haven't heard that in a while.
You want me to get in a nut? Is that what you want me to do?
No. Well, maybe, but you know what? I like when we make things simple, and I like to keep our audience smiling. This
Right.
tech stuff, we take ourselves super serious, and this is serious stuff. Keeping things secured, enabling the future of vehicles, but at the same time, it's the coolest industry on the planet. So you should smile a little bit, because we get to do the good work every single day.
That's true.
Chris, I want to go back to cars. I want to talk about cars because you talked about security. Um, you know, basically there's a continuum of interest in cars, from the L2 plus, just smarter driving, to full autonomy, to robo taxis, to next generation infotainment, to cloud and government, being able to cars and cloud and government all being able to connect at once. But really, the edge is the enabler here. To really any of this to work, most of the critical processing has to happen at the edge. You can't have a car's computer go back to the cloud to say, should I stop now? That's not going to work. So we're seeing all these trends: autonomy, electrification, intelligent cabins, telematics, infotainment, et cetera, et cetera. Where does memory and storage, I guess I want to be honest with you all out there. I know the answer to this, but I want to set you up, because I think you're going to give a better one, being that you do this every day. Like, talk about the role that memory and storage are playing, and why they need to be playing, why it needs to be talked about more often.
Yeah, and you hit many of the points, Daniel, as you were kind of fleshing out the question overall. The electrification of the automobile is really the sea change that we see here. And obviously, EVs are becoming a much greater percentage of the overall light vehicle sales around the world. But that trend alone doesn't necessarily motivate an increased memory and storage footprint in the car. But automakers are taking the opportunity, as they electrify the powertrain, to revisit the architectures which are in these automobiles, right? And so you mentioned a couple things in ADAS, for example, right? Obviously we have radar, lidar, vision sensors which are on the car, which perceive the environment around the automobile. But concepts like sensor fusion and whatnot are really driving the data which is coming off of these sensors, to much greater and greater amounts, right? And so again, memory and storage, very high bandwidth, functionally safe, high density memory and storage products are going to be central to that, right? Because all of that data needs to be brought in off of the sensor, stored in some DRAM memory, and some algorithms performed on it in order to fuse all of those perception streams together and come up with an answer to direct the automobile. And so again, memory and storage very much central to that. And again, this is a mission critical type of application. So a functionally safe memory is going to be extremely important. When I say a functionally safe memory, there's analysis and feature sets that we put within the memory itself so it fails safe, right? So we understand the failure mechanisms of the memory and can take countermeasures when there's any kind of fault in the system. So again, we are unique in how we have analyzed these systems and the feature sets that we put within the products itself in order to enable these types of mission critical applications. So that's on the ADAS side. And really, a lot of the NCAP requirements that we see from the world in NCAP, this is the new car safety assessment programs that are present across the globe. That really defines the safety minimum bar necessary. So really, if we look at the around the world, those NCAP requirements continue to increase, right? So the cars are getting safer and safer. And again, a lot of the trends that I just mentioned here around memory and storage are going to be very well suited to address those increasing needs. But one other interesting thing is the whole in-cabin strategy, right? So when we look at ADAS, that's one piece, and then the infotainment or in-vehicle infotainment types of IVI applications is also driving a big change in the automobile. As cars become more automated, the cabin becomes, a different type of environment, right? Which you are going to be more productive. Your hand's going to be off the wheel. Your attention will be elsewhere. You'll be very productive in terms of maybe working, on your laptop or, maybe engaging with some entertainment within the automobile. And so again, more storage is needed for application storages, right? So you want to put more apps on your car. Again, you need to have more of that data to be more storage in the car in order to store that information. Things like high definition maps, which are going to be supporting the navigation of the automobile. Again, you need to have a high performance, functionally safe memory in order to storage device in order to enable that. And overall entertainment. 4K displays are becoming more prevalent in the automobile, several 4K displays. Again, each of those will have a storage device that sits behind it in order to drive that display and to keep that content. And so it's really, honestly, Daniel, we're in the golden age of memory and storage as it pertains to automotive applications, because without the advances that Micron is bringing forward to the industry, we would not see the growth of these advanced driver assistant applications as well as these IVI or infotainment systems as briskly as we're seeing now.
Yeah, it's pretty interesting, and the pace of adoption has been fascinating. They say about 20% of the vehicle BOM in the next like 7 to 8 years is going to be semis. So it's
Yeah.
just amazing, and I actually think it could be more, and it could happen faster. But fact of the matter is, we are going to move through the levels. We are going to move to a higher safety profile. We are going to move to, more immersive. Like vehicle is a great example of where almost that metaverse story starts to actually make
Right.
sense. And I'll come back to that because I want to ask one more question about the cars, and then I want to pivot a little bit. But you know, in this whole connected vehicle space, you mentioned functional safety. You know, can you just dive in a little bit more what you mean by that? Like, because again, it's not airbags and seatbelts, but Micron has a role to play when it comes to making the car safer.
Yes. So, you know, eh, functionally safe types of semiconductors are going to become a requirement in these mission critical applications like driver assistance. So when ISO 26262 came out, which was the industry specification that we use in order to develop our products against, there was a lot of discussions around things like redundancy. Let's just put two of everything within the automobile, and that will somehow protect us if one system fails, the other one would be able to take over. But that's flawed in many instances. If you have a flaw in one memory, or a systemic flaw, there could be a fundamental error in one memory or one SoC or one semi, which is in one of those systems. If you just replicate it, twice, you're going to replicate the fault twice. And so, a more enlightened approach to making sure that these systems fail safe was needed. And so this is where we put a lot of innovation in place. So obviously, we look at systemic failures as well as random failures. Can we put various circuits in our products in order to detect these failures and then take appropriate action, when they do indeed happen? And so that's unique and for us because in many instances, a lot of this work has to happen at the system level within the SoC, and in many instances that drives a lot more data transfer, a lot more power consumption overall. And so embedding these features within the memory itself really is a more elegant solution on this. It allows us to detect these memories more quick or these faults more quickly, but also do it in a power and performance footprint that is more appropriate for these types of applications here. So we mentioned earlier that we have a low power DRAM, LP5 DRAM, which was our first ASIL D rated DRAM. That is the one of the many that you're going to see coming out in the future from Micron. But also, what's important to know is in many instances, we talked about functionally safe memories being required for driver assistance applications. We're also seeing emerging requirements in infotainment applications. As I mentioned earlier, things like high definition maps and other supporting capabilities are going to be put into these IVI systems that are going to be supporting the autonomy of the vehicle. And so again, today, these are not necessarily prevalent in storage devices, but in the next few years, you're going to see leadership from Micron, and the industry is going to certainly follow suit, where functional safety is going to become much more important for storage devices in addition to just traditional memory devices like LP5.
Whew, take a breath. You've earned it. But no, that's, you know what, it's great that you kind of helped to discern because, in my opinion, like I said, sometimes the critical nature that certain technologies can play can easily be missed. It's like the supply chain shortage. Everybody thought we were dying on the leading edge, and it was like actually so much of what went wrong was we were missing, uh, 20 plus nanometer, legacy
That's
uh,
right.
lagging process, and that's why cars couldn't get finished because the seat heaters and the connectors to the stereos. These are old things that and so it's the same thing here. It's like a great example where tech is really influential in the experience, but we don't always see how it happens. So it's really important to help identify that for the viewer. Now, I mentioned about augmented reality, virtual, metaverse, call it what you will. Part of any embedded story, Chris, has to talk a little bit about the future. Now, we don't have to agree on Mark Zuckerberg's strategy. I said I was on, I did like CNBC and a bunch of other TV shows talking about Meta, and I basically said this. I said, he may not be wrong, but he's early, and I guess in a lot of times in the investment world, that's the same thing. But in the long term, I think this augmented virtual metaverse thing is going to be real. We're going to end up meeting it in the real world, which is why I said in cars, like being able to look out your window and see what an object is, or be able to interact with a restaurant or a retail store, and being able, that's going to be the future. What do you see there? What's the role that you could see Micron playing in that
Yeah,
space?
and I agree with you, Daniel. I think it's coming. It might take a little bit longer, to pull everything together, like you said there. But I think that the benefits are clear, the technology is there, and the use cases continue to evolve that are really going to really enjoy AR VR, right? Just the whole COVID situation that we have been dealing with over the last few years. People are now working from home more. That's really part of the part and parcel of how industries are working across the world. Virtual reality technology, the metaverse is really going to squarely address that, bring people together, virtually in order to reclaim some of that kind of face-to-face connections here. So, as you mentioned, I definitely see the trends in the industry as we speak with industry leaders in this space, both companies such as Meta and the like, but also the various chipset vendors that are out there that develop the SoCs that go into these applications. It's all a very positive story. It's not a matter of if; it's simply a matter of when, and getting that at the right time. As you mentioned, what does this mean for memory and storage? Again, many of the things that we have talked about here on the edge apply. But I think that when you look at AR, VR, there's some interesting requirements. These things have to be small, lightweight, and consume as little power as possible, right? Many of these AR, VR systems are on a battery. And so low power DRAM that has extremely low power is going to be very, very critical here in order to make sure that that battery life has as long a life as possible, but also size, right? So we have a multi-chip package strategy that allows us to integrate both DRAM and NAND device memory and storage together in a single package, again, to get a very small form factor that can fit into some of these portable devices. And so we have engaged the marketplace, not in AR VR, with these types of technology, things like telematics and machine-to-machine communications in the industrial space. So we're taking a page from that playbook, continuing to reduce the size, continuing to drive for lower and lower power, and deploying that into these emerging applications of AR VR. So again, a lot of our investment that is targeted to the industrial edge. I think that these emerging applications with augmented and virtual reality are really going to enjoy those that innovation. So,
And no one can forget that symbiotic relationship between memory and compute that not going anywhere anytime soon. So we only have a few minutes left. I'd love to end the conversation just talking a little bit about that, that rugged industrial environment. So, there's a lot of trends there. I've been to countless IoT, Industry 4, and we do know that some of the most compelling and immediate applications for embedded at the edge do take place in those environments. Any big trends there that you see? Kind of how are you and your team at Micron supporting that space?
yeah. So it, as you mentioned, Daniel, really there's a lot of commonality across these various market segments. And if you look at industrial, you mentioned ruggedization, right? These are typically harsh environments, wide temperature ranges. There could be moisture. There could be a lot of other things, that are really from an environmental perspective, making that system, have to operate, in those extreme environments. And that is not so unlike automotive, for example. Again, another very harsh environment, extreme temperature ranges, very long life. And so, again, all of these edge applications across the board, we see the drive to more ruggedized products, more robust products. And so when we look at the industrial edge applications, we take a lot of the use cases that we see in automotive and we apply that to our qualification schemes for our memories that are going to be targeted to industrial to ensure that they are very ruggedized, robust memories that can operate in these very harsh environments. So that's a big piece. So we want to make sure that the components that we deliver can deliver the performance and capability in those harsh environments. But we also engage with various partners across the industry. So we have our IQ engagement, which is our industrial quotient engagement, where we basically work with a select group of integrators that will take our products and then place them in a module or in a subsystem that is further ruggedized. And so we engage with these broader ecosystem partners. We have confidence and they understand these applications very well. So they can take our pre-ruggedized memory and put it into a system that will also be ruggedized, that will be very much fit for function into these types of applications. We see a lot of consumer grade types of devices which are being brought forward in these types of industrial applications. And we really don't think that that's the really the right way for the industry to approach this. Many of these ruggedized environments, are mission critical as well. They could be automated robots on an assembly line or a medical device of some way. And so we definitely want to make sure that, again, just like in automotive, that these devices can operate under those harsh environments. And again, we use a broad ecosystem engagement here with partners to make sure that they are delivered into a system that can support that.
Chris, I think you've covered a ton of ground and we've used our time together really, really well. I think if you look at the announcements you've made, Micron, and really what the story you're telling today is a comprehensive contribution across the stack from devices to the intelligent edge to, integrations in the cloud and the data center to industrial. Now, I know you're responsible for intelligent edge, which means some of those things are more directly yours, but we all know that the way connectivity works is these things all have to play together. And the technology that you're building seems to really be making a meaningful impact in that area. I want to thank you. I know I know you haven't been there that long. So I'm super impressed at how well you got the story down. I talked to a lot of executives here on the Futurum Tech Podcast interview series, And I would never have known that you're not a wily 20-year veteran. But I want to say thanks so much. And I hope that in the near future, we can coordinate having you back on, talk about how some of these things are advancing.
Daniel, I would love it. Again, I'm so excited to be here at Micron. As you mentioned, we are at the forefront of a lot of the innovation that we're talking about here. Memory and storage is the foundation upon which these applications are built. And so, again, looking forward to future conversations between us, Daniel, so we can talk to you about some of the things that we're going to come out into the future. But thank you.
Yeah, absolutely, Chris. Thank you. Hey, everyone out there, hit that subscribe button. We'd love to have you be part of our Futurum Tech podcast community. Lots of great interview series, lots of great other shows here. So much to learn from all of the technology partners and, of course, the analysts on the Futurum team. For this episode, though, it's time to say goodbye. If you need more info on anything we talked about, check out the show notes. Again, thanks for tuning in. We'll see you all really soon. Bye now.